Good morning, and thank you for attending Blue Water's webinar, Headworks Smell Like Lost Money. My name is CJ Strain. I'm the CTO for Blue Water Technologies. I'm a professional chemical engineer, and my primary focus in wastewater is really in process development. I've met many of you at WEFTech and at local conferences, and I look forward to the Q&A session, which we'll have at the end of this webinar. The format for this presentation will be very simple. We'll start with an introduction to the challenges in treating water, primary treatment, Headworks, and then we'll transition to a process technology that meets some of these challenges that we highlight. We'll then wrap with Q&A, that Q&A from the audience that I mentioned. Now, if you're on here and you would like to receive a certificate for PDHs, there will be a contact email address on the screen at the end of the presentation. For groups, if you have multiple people in a conference room under one email address, if the meeting organizer could just compile a list of attendees, make sure that attendee names are on the list with their state of licensure, then that way we can get PDHs out to individual attendees. And also I encourage you to stay active throughout the presentation, as we can only give PDHs to active attendees. So let's jump into this webinar. The technology that we will focus on today is the rotating belt filter, our EcoMat RBF. We're in the picture we show a 3.4 MGD EcoMat unit in perspective with a conventional clarifier, and you can see the direct footprint savings. The EcoMat filter is a 4-in-1 process. Basically, you get your screening, your grit removal, your clarification, and your sludge management and dewatering in a single unit. It's a mechanical screening clarification device that gives you all of that in your dewatering. So we'll highlight some of the design features of that, some of the cost savings features of that as we go forward. The level of treatment and treatment efficiency is dictated by our design and operating parameters. And these parameters are customizable to the application, to the end user's goals. Our focus being the EcoMat rotating belt filter, I want to give you a brief overview of Blue Water's background and history with this technology. So I'm going to briefly tell our story to begin this presentation. Then I'm going to define a rotating belt filter and share some good videos and pictures to demonstrate its flexibility, its method of operation, and generally what it looks like. This slide contains several pictures from rotating belt filters operating around the U.S. And here you see a head roll with the mat of solids being cleaned from a rotating belt filter device. So this device is installed with raw sewage coming into it. So this is before any screening, grit removal, etc. Just raw wastewater, and that collects on that mat, that rotating belt filter, and that's cleaned off and discharged into a sludge hopper, which you can see a dewatering device squeezing the solids from such an application down to about a 30% dry cake. So I'm going to start again by telling you Blue Water's background, Blue Water's story here. And Blue Water's really grown up in the USA. We're a USA manufacturer. Blue Water as a company is about 10 years old now, but we grew from a couple of other companies that have a good 20 to 30 years of wastewater history in the United States. So we're a US-based manufacturer. All of our units and operations are, as much of our components as possible are made in the USA. We produce turnkey solutions and unit processes. So we focus on unit process efficiency, like our EcoMat rotating belt filter. I'm going to share some of the ways that we've developed that product line. But we can also focus on turnkey package solutions as well for the industry. We've done a lot of package plants. We do a lot of mobile systems for not only for like contract work, lease options, remote systems like you would have in some of the mining camps to treat sewage works. But we also do, contract treatments for pilots where we're delivering turnkey systems that need to be delivered to a site and online within a day. So we have a very capable manufacturing and an operations and service team for those scenarios and those kinds of applications. We have a UL listed panel shop, which gives us a lot of flexibility and delivering and integrating to existing infrastructure and existing control systems. So we can tie in our PLCs for equipment seamlessly into existing SCADA systems, etc. That's Blue Water's capability. We have a culture of customer service. And with that, I'm going to start talking about our rotating belt filter. Blue Water has been providing rotating belt filters, installing and servicing them for 8 years in the wastewater industry in the United States. Now, with that level of design, service, etc., well, let me back up a little bit. Rotating belt filters as an umbrella, the technology, is about 20 years old. It started in Europe. And so with that 20 years of history, it's a very well understood process, a very capable process, very well modeled as far as the operations go. One of the issues that we see bringing technology into the U.S. Is that a lot of the technology was developed a while ago. It's been proven, but it hasn't been improved upon as the need grows. So rotating belt filters had been fairly stagnant. And that's where Blue Water, through our design, implementation, and service history, really learned a lot of ways to improve that technology and answer the industry needs for an improved product line. So Blue Water launched our product line in 2012, the EcoMat product line. And what we focused on was really ease of operation, ease of service, and a reduction in overall costs. So these systems are fully modular, they're fully automated, they do operate essentially by themselves. Everything's automated with level control, pressure sensors, etc. And I'll highlight the features of that as we go forward here. But essentially you get this very high rate of clarification without chemical usage in a very compact footprint. So that screening, the grit removal, and the clarification, it can replace a huge amount of infrastructure. And there's different motivating factors to this. Some of it is simply cost-based, where you can get a payback if you're doing a plant upgrade versus conventional treatment. Some of it's getting aerobic capacity back, taking some of the load off of the secondary system. We've installed a lot of systems in the southeast for that reason. But ultimately what you get when you contrast rotating belt filters with conventional treatment is you get a very superior performance, superior TSS reduction, particle size control, hair and grit removal, etc. These are great in front of membrane systems for that reason. So, and when we look at new applications, as I mentioned, there's a lot of different reasons to consider rotating belt filters. But as far as the design considerations behind implementation of the technology, it's actually, we can start with the baseline that we use when we're designing, any Headworks system or any primary clarification system. And really what we're looking at is the level of treatment, the treatment quality. What can we get to X with implementation of rotating belt filters? And typically we're removing anywhere from 30 to up to 80% of the TSS with rotating belt filters, in addition to maintaining a good particle size control going into the secondary system. And with that level of treatment, we have a high level of simplicity. You'll see this when I share a couple of videos that will illustrate how this system operates. It's a very simple system that produces this high level of treatment, and it's very easy to provide a multi-barrier approach with this because of its modularity. Now, as we've developed this product line, we've really focused, like I said, on ease of maintenance, which is a very important consideration. It's not only a cost savings thing, but that'll also tie into safety, which of course is another big consideration for Headworks design. We have to look at confined spaces, how much rigging, how much heavy equipment is being manipulated by operators. And in addition to that, we're looking at the environmental and odor control requirements as well. Now, these are enclosed systems. They do a great job at containing odors, etc. And again, as we go through the videos, you'll see some of those properties. But essentially, the bottom line to all of these points is cost savings. Cost savings with a capital project and cost savings with throughout the life cycle of the equipment. So as I mentioned, the bottom line, it's cost savings, it's money. And this is yet another image that brings that concept home. You can say money in terms of space, as we've shown, contrasting the 3.4 MGD EM30 to conventional clarifiers, or you can say it in terms of capital costs, which you look at a conventional clarifier. And this can be a picture with Headworks as well on here, because there's a lot of earthwork involved. There's a lot of underground buried pipe involved. There's yards and yards of concrete. There's a lot of resources that are involved in costs that will go into a conventional clarification tank. Now, they're very simple and they're effective, but they are very, very costly. Now, you contrast that to the compact modularity that the EcoMat rotating belt filters bring. Now, this is a shot of our production floor where a tech is putting together, and he's actually working on an EM3 machine. And that's a 0.5 MGD capacity unit there. So again, you get a very high level of treatment in a very compact footprint. And you have two drives on that system there. It's a 1 horsepower belt drive and a 1 horsepower auger drive. So very low cost of, very low input to cleaning the belt, to operating the system. There aren't any blowers involved. That was one feature that was used in older systems that was added to the expense over the lifetime of the system. And with these rotating belt filters, you'll see that they're very economical to own. I'm going to pause for a brief video. The first video that I'm going to share is a video. It's of an EM3 unit operating, which is a 0.5 MGD unit, and it's operating at capacity, just so that you can see what they look like in person. So again, as I mentioned, this is an EM3. This is the influent water. The influent would come in through a pipework and enter this influent bay. This is on a level control with a flush wall-mounted sensor. We call it a foul-free sensor because it reduced a lot of issues that we had with plugging with some of the older styles that we used to provide to the industry. So that was an improvement. This level control bay is really controlled by the sensor tied to a PLC and the drive on this belt that's discharging, the mat then discharges the captured solids over into this solids collection bin that you see here at the bottom. So this represents a very high capture rate, roughly about 60% of the influent TSS, and that's, again, doing your screening and grit removal here as well. That sludge is discharged to a sludge bin, and then it can be conveyed to a compaction section, which you see here. And that integrated dewatering provides roughly a 30% dry cake. Typically, we can get higher, but it depends on the economics of squeezing the additional water out of that. This bin is actually designed to aid in that dewatering. There's a perforated plate in the bottom that allows further dewatering without a lot of compression and energy involved. So that's an EM3 system in operation. Again, what you're doing here is 4 processes in one. You're getting your screening, your grit removal, and your clarification, and then your sludge management. And my next video is an animated video that will highlight the mechanism of capture, the mechanism of removal, so that it's a little bit more clear. I'm just going to skip ahead here. What we have here is our EM30 unit being highlighted here as we go around the unit so that you can see the different features. Again, we would have a wall-mounted sensor in that influent bay. And when you contrast it again to conventional clarification, we're roughly 5% of the footprint. And that becomes even more important when you're in bigger plants. If you're in a 15 to 20 MGD plant where you have multiple units. Now this is a very mature product line, like I mentioned. We have multiple units within the product line ranging from 100,000 gallons per day flow, with our largest unit flowing roughly 3.4 MGD. Now this is all based on typical primary sewage influent, raw wastewater, typically between 250 and 350 milligrams per liter TSS. So that's what those loadings are based off of. Those loadings will change with solids. We are in some industrial applications where it's thousands of milligrams per liter coming in, and we will derate the equipment slightly. So when we look inside of the EcoMat machine, again, this is a cartridge-mounted rotating belt filter, so you have a continuous loop mesh. This influent well, which we see animated here, again has a pressure sensor in it. So we can maintain a level control through a PLC, and really what maintains that level is that this belt is driven by a motor, again through the PLC. And that PLC is reacting to the head level, which will change as the particulate from the influent wastewater builds a mat of solids on this rotating belt filter. So that's really the key behind this technology is controlling that mat thickness and getting that removal. So initially you're getting screening to this pore size of the mat, but then you build up that solids mat and you're actually getting filtration through it. And then you get the integrated conveyance of that sludge, of that captured solids, up into the sludge conveyance bin. And then dewatering is an option. This is a very robust dewatering design that Blue Water has worked on for many years now. We've provided dewatering equipment to the industry, and we integrated some of our best designs into this EcoMat rotating belt filter product line. Now, dewatering is an option. There are many plants that might have anaerobic digestion on site where they don't want to dewater. They just want that high level of solids brought into their digesters. And coming off the belt, those solids are roughly about 10% dry solids. Now, when we're talking much larger plants, we can also install these rotating belt filters in modules. And it's very easy to get your redundancy with this overall design. Now, these are for very large plants typically. I do have a couple of plants that are, 5 to 10 cartridges, anywhere from, 10 to 30 MGD design flow that are going with this channel mount design. In fact, some of the largest, or I would say the largest installation in the world for this technology, the rotating belt filters, is a very large plant. It's over 100 MGD in Mexico. Actually, it peaks at 300 MGD. So a very large capacity with this modular layout style. And you can see the space savings potential for this technology and equipment. So I hope that gives you a good idea of how the system operates, the method of removal, etc. Over the next 3 or 4 slides here, I'm going to share some of the case history that we have for the rotating belt filters and illustrate some of the different ways that it's been configured for operation. This first one has actually a really good story behind it. The city is Plummer, Idaho, and we brought an EM15 EcoMat system down to Plummer. Now, they had a big problem with their Headworks, so it's very appropriate for our topic today. Their issue was it was actually a fairly new Headworks building, but they had installed screens for their primary or the Headworks screening and grit removal. And you can see those screens in these pictures. They're still in this plant. The issue with these screens is they had no automated cleaning, no degreasing, so the operator was getting up on a ladder and he was pressure washing these screens with hot water every single day. So we mentioned, all the considerations that you think about when you're designing a Headworks system, and there's so many reasons to fix that solution. One is the cost and the time spent cleaning these screens, but also the safety. You're up on ladders, you're working with high pressure hot water wash to degrease these screens, etc. So huge issue. And the way that Blue Water helped to solve this issue with an EcoMat was we simply put one of our contract systems on a trailer. And this is a system that is designed for roughly 1.7 MGD, which easily took the plant flow of 1.1, and provided them with a very effective solution for their screening and grit removal, and provided a nice TSS reduction as well. In fact, here's the operating chart. You can see that the plant is on a lift station. It's on off. They get some pretty good swings in TSS whenever that pump cycles. But another nice feature of the EcoMat methodology, the operation, etc., is that you get a nice dampening effect of those TSS peaks along with the removal, and that's really nice to provide a little bit more continuity through your secondary system. Along with that, higher levels of TSS capture, you do get a significant amount of BOD capture as well. This one got about 35% BOD capture in those solids, which is great for overloaded plants, and that can be slightly customized with the mat sieve and different PLC settings to either give you an effective screening solution with minimal TSS BOD capture, or we can go with a finer sieve and different PLC settings to give you those higher capture rates. And then I mentioned the integrated screenings, dewatering, sludge management. You can see that pictured as well. This next case history is actually an industrial application, but I wanted to share it because it illustrates the flexibility of the EcoMat system. Excuse me. The EcoMat system is very capable of handling very high TSS streams. Now, this is a pasta producer in the Midwest. They have anywhere from 3,000 to 5,000 milligrams per liter TSS in their wastewaters. Now, they were having issues meeting their TSS target in their effluent before we brought this rotating belt filter in. We did some jar tests. We optimized the chemistry. This one we did add chemistry to because they needed a high 80 to 90% TSS capture rate. So this system illustrates, good planning on the part of the engineer. Blue Water got involved with the jar testing, the pilot operations for the engineer, and then I believe it was actually the engineer that purchased the system to get them, and again, it was within 30 days of having tested because it got them the solution they needed, and they were installed with a EcoMat rotating belt filter. But again, handles TSS very well, handles high fog and fats very well as in addition to that. The next case history I wanted to share with you is another municipal case history. This is in Post Falls, Idaho. This is an EM3. So it's a 0.5 MGD unit. This was actually a pilot system that was brought to the site. They're in more of a 5 to 10 year plan for upgrading. They currently have grit removal and fine screens going into their secondary, so no primary treatment. And in the next 5 to 10 years, they're going to be upgrading that plant. The target here to model the system for their design was to achieve 50% TSS removal, get them their screening and grit removal, and dewatering as well. You see the operating line in this chart here. That's representative of roughly 59% TSS removal, so met that target, and got roughly 38% BOD removal, so we met their target with BOD screening and grit removal as well. Now, on this particular pilot project, we demonstrated that we can actually adjust our dewatering settings to achieve anywhere from 25, well, 20 really, you can back that off, but up to a good 45% dry solids with the sludge management. Now, again, that's a balance of energy input to dewatered solids and your trucking fees. And you don't necessarily want to dewater if you have digestion on site. So, and also in that case, you might not want your screening and grit in with your sludge going to a digester. But those are all design considerations that Blue Water and engineers have worked on, very closely in the past, and I'm sure we'll work on together in the future. This is another case history where we're doing the screening, the grit removal, the primary clarification, and sludge management. Another EM3 unit. This is actually a full-scale unit. The treatment design flow for this plant is 0.4 MGD, so it's a slightly smaller community plant. The goal was 50% TSS reduction. Really, though, they wanted their screening and grit removal. The TSS wasn't as important to them, although you see the performance of the system here on the screen. You do see they have a lot of rags coming in. This is a it's a community. It's an assisted living community, actually. Not that their wastewater is a whole lot different than anybody else's, but in this particular application, the plant has no screening. It had nothing, actually. So it was just taking the raw water and screening, removing all of that TSS, and then dewatering and compacting. Now you see a very dry cake here. Again, we can back off the tension, the back pressure, to give anything between a 20 to 50% TSS cake or TS cake. And again, our target really is one, pass the paint filter test so that you have a lot of disposal options, and to make it as economically as possible to manage the disposal of those that sludge, that cake. This last project that I want to share with you is actually a combined sewer project. And I think this is going to come up a lot in the middle U.S., where there's a lot of combined sewers. There's peaking events due to infiltration, etc. Those applications are ideal for, or I should say the EcoMat rotating belt filter is ideal for those applications. We can manage a very high peaking factor. This case history actually had a 10x peaking factor, and the deliverable really is to meet that discharge target for TSS so that the site can simply disinfect and discharge during those high peaking events, where appropriate. So we went into this project and we were aiming for a minimum of 60% TSS reduction. We were actually able to average 70, and we actually pushed it, as you can see in this chart. We pushed the TSS removal up to 80%. And this is all about adjusting and really customizing the operation parameters. There's no chemical involved. It's simply the EcoMat rotating belt filter. And we go in with a smaller pore size for this kind of application, and then just adjust the PLC settings so that belt movement is very slow, and we're building up that particulate of that mat of solids, and that mat does our filtration and screening for us. And again, the slower we move that belt, the more capture we get. So we might have to derate the equipment slightly hydraulically and go with a finer mat, but it's very capable of meeting these primary treatment goals in CSO applications. Most projects for us begin in the lab. We have a very capable operations team that can do bench process simulation for new applications. We use this a lot more in industrial applications, but we have used it quite extensively in municipal applications as well. I would say we did it more 8 years ago than we do now, because we have quite the installation base and reference list now for municipal projects anyway. But for a lot of industrial projects, or even if we need a few data points on a municipal project, we can do bench tests where we basically use sieve discs, and we'll pour water through these discs, and we'll look at the formation of a mat, the thickness of the mat, the porosity of that mat, and its capability to do further filtration in our rotating belt filter methodology. So that's something that we can do on a bench scale. We can bench scale actually all of our product lines. We do it with Blue Pro systems, our clarification systems, other than the EcoMat, like our EcoDAF, Eco IPS 55s, and our press dewatering, etc. Now, I've mentioned that we, that's a first step into a lot of different industries. Here's a list of the different industries where we have experience with rotating belt filters. And we're actually getting a lot more interest in the EcoMat because of how much we've improved the technology with energy reduction and serviceability. I've talked about grit removal, fine screening, primary clarification. I would say one of the biggest, or a couple of the biggest growing applications in the municipal world are as membrane pretreatment. Screening, getting all that grit, hair, plastics out so that you're not fouling membranes. That's a huge application, and I think we're going to see that grow quite rapidly over the coming years to protect membrane plants, whether they be MBR plants or plants that have tertiary membranes. Sewer overflow I mentioned and highlighted as well. We've been in a variety of different industries. We have installations in the dairy industry, applications in pulp and paper, textiles, tanneries, etc. So, and I mentioned oils and greases. It handles oils and greases very well. We see a lot of that in the meat processing industry with poultry and beef kill. We can see TSS up to 5 to 10,000 milligrams per liter. We can see BOD in the several thousands. And this system is very well designed for managing that loading, again, according to our design parameters. You can see that the mat that forms on the EcoMat is actually very different for each application. Here's a primary treatment application where you see kind of a light brown. You get a lot more of the toilet paper in there, the fibers, etc., and it looks like raw solids. In these other industrial applications, you see the color and texture and the density of that mat change depending on the application. So textiles, for example, has a very porous mat, very dark in color in here because this is right after a dye process, but very high capture rate there, very porous. Poultry, pasta, dairy, they're very dense mats, a lot more fog, a lot more BOD involved in this capture as well, a lot higher TSS. So you can see the difference in those mats. And we've done a lot of work now in algae capture where we're harvesting algae, getting anywhere from 60 to 70% TSS removal, getting appropriate algae capture for various algae farms. So there's another application that we've done in the past. And I just thought you would like that. It's a fun slide for me more than anything else. This slide here shows some of our pilot equipment. I've mentioned our operations program, our bench testing and lab capabilities. Typically, after that step in a design phase, we're doing piloting to get on-site design parameters, for a given customer, for a given end user. And we have a very mobile pilot and contract treatment operations program for that. You can see some of our turnkey systems on trailers here in operation. That's a DAF system. This is an EM3 rotating belt filter. All of these systems can be mobilized to a site and they can be online within a day of arrival. We have them very well designed for field service. And again, the different reasons for doing field service or contracts or leases, etc. It could be treatability in design projects. It could be contract treatment through construction and implementation phases. So there can be various reasons for doing this, and we again have a very capable program for that to fill that need. I want to take a look inside of these cartridges now and just give you an idea, give you a closer look on how on what the inside looks like, how they operate, the key design features, as I say. Now again, this is a continuous loop mesh that's mounted on a cartridge. It's a polyester mesh, self-aligning belt. There's a multiple sieve sizes available, as I mentioned, to customize to an application. But the nice thing about these cartridges are they just sit in the channel by gravity, or in the containment by gravity. And there's a seal plate on top that separates the influent from the effluent, which would be underneath. The influent would hit this baffle. This entire bay would fill up with water. There's a wall-mounted pressure sensor that's flush with the wall. The way that things used to be with older designs, and there's still a couple of players in the industry that still use these old designs, where they basically have a vertical pipe, a still well, if you will, where they will suspend a pressure sensor into the influent well. Now, the shortcoming of that is you get solids build up around that sensor, and you get a lot of faulty readings and failures, and it's a maintenance nightmare. You have to clean it daily or weekly or whatever that frequency may be. So we got away from that. We especially had problems with that in our poultry industry, and thus we got a new nickname for this configuration, this patent-pending pressure sensor configuration. And we call it our foul-free sensor because in those days when we were in poultry plants, we'd get a lot of feathers and just ridiculous things building up on that. So that's one nice feature of the EcoMat product line, is that patent pending pressure sensor integration. Another thing that we've done is we've improved the maintainability of the cartridge, made it easier to lift. Now, older cartridges and some of the other cartridges that are available in the industry, they'll pick from both sides of the frame. So they would attach their gantry from this ledge and this ledge here, and they would hoist the cartridge out of the channel. Now the issue with that is now your gantry spans the belt. You have to take it somewhere and disconnect it. You have to put it on a fixture or whatever to do a belt change or to do any maintenance on the cartridge. So Blue Water, again, improved the configuration and added a patent-pending lifting gantry on this system that only picks from one edge. You can lift the cartridge out of the channel. You can do all of your maintenance without having to take it anywhere and set it down or place it in a fixture, etc. So this is not only saves time and rigging, but it's also a huge safety improvement too, because you're not detaching, attaching your rigging, etc., and doing maintenance as often or as intensely as had been done prior in this in the industry with this technology, this umbrella of rotating belt filters. So those are just a few improvements as we look inside the cartridge. Another improvement that I'll briefly highlight is I mentioned that some of the older systems use blowers. And there's several reasons not to use blowers from an operational standpoint. But I will point out that our cartridges use a very low energy input cleaning device. And that cleaning device is a doctor blade. It does a very efficient belt cleaning, does probably 99% of the work as far as the belt cleaning. And in this next picture, you'll see what else is part of that belt cleaning system. Now, we have intermittent hot water degreasing, which is something that is pretty standard across the industry, across the different manufacturers of rotating belt filters in general. So this is an inside-out spray and degreasing system. You see a cross-section of a rotating belt filter here. So as the solids would collect here in the influent well, and they're conveyed up out of the water and discharged to the sludge bin, our doctor blade would be on the header roll discharging the solids, and then our degreasing system would follow the doctor blade in sequence, blowing from inside out again. This is a periodic degreasing. It's programmable. It's set up on a timer, so it typically will cycle on for 2 to 5 minutes, and it could be 1 to 2, maybe 1 to 6 times a day would be realistic. I would say it's much more in industrial applications where you have higher fog, higher grease. A lot of our applications, they might degrease once or twice a day. And I do want to focus on the fact that Blue Water's intention with this system, this cleaning system, was to reduce the energy cost, because one of the issues with this technology, again, it's 20 years old, the rotating belt filters, and they started out with blower systems, and the blower systems, they work really well for cleaning. I mean, they're effective is a good way to put it, but they would span the belt with an air knife, so you had this slit that could be clogged or whatever. It was usually pretty reliable. But the other thing about that, other than a maintenance issue, was the continuous cost. You had a 15 to 20 horsepower blower on a 2 to 3 MGD system, and that's a huge amount of energy input that is just simply unnecessary. We're doing the same cleaning without that, so we were able to reduce the total energy input to the system by 75%. Another thing that Blue Water did was, for ease of maintenance, ease of access to the system, is we have a patent pending access hatch where we are able to remove and maintenance the spray bars, the cleaning mechanisms, etc. And that's something that you'll not see anywhere else in the industry either. And what that does for us, those quick accesses, that allows us to maintain parts of the cartridge without removing it from the container. So again, for safety, time, ease of maintenance. And with all of these improvements, Blue Water has really focused on servicing a pretty wide range of flows as well. You see the different models that we have available on this in this table, anywhere from a EM1, which will do roughly 0.1 MGD, up to an EM30, which has a 3.4 MGD single unit capacity. Now again, these can be installed modularly. Typically, we'll go with a duty standby unit for redundancy in many applications. Other applications might just have a side screen, static screen for backup, so to speak. We also have a unique feature in our product line, which is an EM30D. The D stands for duplex cartridge. So it's a single unit that would have two cartridges, so you get your redundancy within the same unit. Now, I did mention that Blue Water offers a dewatering press line. Excuse me, it's something that we've done for many years, and it's something that we integrated into our rotating belt filters. One of the drawbacks that we found in the industry servicing the rotating belt filters for so long, some of the older product lines that are available in the marketplace, was that their dewatering was really undersized. I mean, there were all of the maintenance. There were many maintenance things that we overcame with our EcoMat product line, as I've described. But another of the design features that was definitely a shortcoming was the dewatering. Sometimes in the applications we would struggle to get a 20% dry cake. And in fact, with some of the older product lines we used to provide in service, we actually had to retrofit the screws. So when we launched our EcoMat product line, we actually used our screw technology, which is, got a great history, very capable history. And we integrated that design on our rotating belt filters. They've been used in a lot of different applications. We have several different sizes of screws. On our EcoMat filters, we have anywhere from a 3 actually up to a 10-inch screw as a max on these systems. Now we do have much larger screws up to 16, 32 inches kind of thing for the standalone product line. So I want to wrap up this conversation with the EcoMat assurance. We've covered a lot of benefits of the rotating belt filters. You've seen case histories with the TSS removal, the screening, the grit removal, the dewatering and sludge management. The nice thing is with the above ground systems, all of the piping is exposed for access and maintenance, and you're reducing the total volume or the total amount of piping and management infrastructure that you would have with conventional clarification, screening options, etc. We do have a lot of different materials for construction that are available. Our standard is 304 stainless, but we can provide in 316L. We do have some industrial like pickling processes where we've installed the equipment with high chlorides where we'll actually supply in a 2205 stainless. So we're flexible in that regard. Now, I do want to highlight that we've focused on minimizing the power input to these systems. There's no blowers, there's no blower lines, there's no vent lines. So those are all money-saving. That design is a money-saving, economizing design parameter. We use doctor blades and pressure spray bars basically to keep the belt clean very effectively. Again, roughly a 75% power reduction over what was available in the industry before. Now, we do have also some of the highest capacities in the market for single unit processes. That was another shortcoming in our mind that we overcame by designing our systems to meet stated capacities. On our literature, we only state the capacities at which we've tested. So that's something that you can be assured of with the EcoMat brand. And again, we've built this product line for accessibility, for ease of maintenance, to minimize and reduce the overall life cycle cost of the rotating belt filters. And I gave an example earlier of the foul-free pressure sensors that we've designed and integrated into our systems, which you actually see mounted in this picture here on the sidewall. So now I'm going to end and open up for questions. If you have any questions, please use the GoToMeeting interface to type in your questions. We have about 10 minutes before our time is up today. And again, if you're attending and want to receive PDHs for your attendance, please email the address on the screen, mmcphee@bluewater-technologies.com. Uh, and again, if you're in a group, please have the meeting organizer compile a list of attendees with their state of licensure so that we can issue those PDH certificates. If you have any additional process questions when we're done, please use the contact email address on the screen. So again, if you have any questions now that we can address for you, please type them in on the GoToMeeting interface. And it looks like I have several questions. And the first question is about sludge management, what to do with the unstabilized sludge. And I would say that most plants that we've installed and serviced over the years, they do send the sludge to landfills. Now again, the sludge will pass the paint filter test, and usually that's all that's required. So that's one option. I will say that we've done some other sludge management or disposal options for folks. We've worked with a couple of other companies. It's not really our expertise at stabilizing the sludge, but there are a couple of companies out there that will actually do, and this was actually done at one of our installations, where they took secondary and primary solids, blended them, and did a rapid composting process, and they were actually able to achieve like a Class A biosolids in roughly a 30-day composting period. So there are other options out there for stabilization. I mean, you can do lime stabilization and potentially get to Class B with screening of any metals or plastics. So there's options, there's associated costs with each of those options, and I think most of our installations so far have simply looked at the landfill as the most straightforward and economical, but it might vary regionally as well. The next question is, how does the grit removal compare to teacup and other grit systems? So the grit removal with rotating belt filters is very comparable to other grit systems that are available in the industry. We're actually, very comparable to, well, I'm not going to, start rattling off a whole lot of brand names, but basically, if you have a grit classification that you need to meet, please contact me, because we probably have some data on that. And if we don't have specific data, like if you have a specific classification that's much lower and an uptake and capture rate that's much higher than what we have in our data set, we can always pilot and demonstrate that to you. But again, we can customize the belt sieve to get to pretty much any grit classification that you might need. The next question that I have in the pane is, if a plant is going to send the unstabilized screenings, grit, etc., to a primary sludge or primary sludge to landfill, how are the solids transferred, and how are the odors typically managed? So in most applications, we do the integrated dewatering. Most of our plants so far have been smaller, I would say under 7 to 10 mgd, where they have 1 to 3 units kind of thing. And a lot of times they'll just use the integrated sludge management and dewatering on the unit, and they'll again collect it in a dumpster, as you mentioned, a dumpster or a roll-off, and that would be collected and taken to the landfill. Now, there typically isn't a whole lot of odors when you get to the dry solids we're talking about. Again, 30-35% dry solids. There's not really any odors that are generated over the time period of collection. Most of our installations, their collection periods are short enough to where you don't get evolution of a lot of gases or odors, etc. And the units themselves are fully enclosed, so it does a very good job of managing the odors, I guess is the short answer. Okay, the next question has to do with B&R processes and nutrient ratios, etc. And I will say that Blue Water has installed one system in front of a B&R plant with very positive effects. I believe so far it's the only system that's been installed in front of a B&R plant in front, worldwide. And it's operating very well. The nice thing about the rotating belt filters is, yes, it removes TSS, it removes BOD, but it's also removing particulate fractions of N and P as well. So you have to look at your ratios, of course, on each application to really optimize that removal and that performs those ratios. But it's very effective. Now, in front of some B&R plants, you might not want the high TSS capture, the high BOD capture, but you might want the screening and some clarification, in which case we put on a very porous sieve. We look at the POC and user settings for operations on a day-to-day basis, and maybe your BOD target is 5 to 10% removal. So that's something that can be customized on a user level for these rotating belt filter systems. The next question I have is about piloting costs and how to get a demonstration at a plant. Now, it looks like, well, Blue Water has several projects in design throughout the U.S. The Midwest especially is very busy for us. So we have several pilot systems that are very active in the Midwest and in the Southeast. We've just had a pilot system move out of the Northeast as well. So we have pilot systems available for piloting. It's a very simple process. Typically, we'll plan about a week with a fairly intensive sampling protocol. But again, they're pretty painless. I would say contact your local Blue Water rep and talk to him, tell him that you need a pilot and we can get pricing for that, or contact a Blue Water regional manager and they can certainly answer your questions for your specific project. But we have, like I mentioned, several projects in design around the country. I know of a few projects down in the Southeast, again, like in Florida, that are like 9 to 10 cartridge or filter unit projects, and they're currently looking at piloting options as well. So another question is a very good question, is what is the typical belt pore size for a conventional activated sludge plant? And the next question is about B&R. So again, I can contrast that to you because that's a really key difference or a key control parameter for achieving a TSS BOD removal target. In most conventional activated sludge plants, we're using about a 350 micron opening for our meshes. And that's pretty standard for us across all activated sludge plants. We might go down to a 250 up to a 350. But it doesn't vary, and the hydraulic profile really doesn't vary significantly from plant to plant either, going through our belts. Now, if we're going in front of a B&R plant where you want more of the screening benefits, the grit removal benefits, but not the high TSS capture and the BOD removal, where you want to kind of minimize that BOD removal, we would probably open up that mesh to maybe a 500 or even up to an 840 mesh size. Those are a couple other standards that we have. So I hope that answers your question in that regard. The last question that I have is, yeah, we're about out of time here, so this is the last question I'll be able to address for you today. Again, if you have additional questions, please feel free to email the email addresses on the screen. But the last question has to do with pricing, and pricing is definitely going to be tied to specific applications. You know, with these rotating belt filters, I will say the larger your plant and the more modules you have to spread out your initial capital costs, just like with any other technology, you're going to get more economy in your pricing, your cost per gallon. But I would say that installing a system, you can be anywhere from, maybe 8 cents to 80 cents per gallon per day. And you're going to be at that 8 cents per gallon per day, on your higher flows, maybe a 3 MGD plant or so. If you're doing a small package plant, 0.1 to 0.4 MGD, and you're having to install a small unit with all the ancillary controls and everything, the cost per gallon per day is going to be up a little higher. I hope that helps a little bit in scale. They're very economical systems, I will say that, and their cost of ownership for treatment quality that you get is very positive. So if you want specific projects designed and priced for you, if you're doing a study in that regard, please contact again your Blue Water rep. I want to thank you all for joining me on this webinar. I hope that I've given you all a broad overview of the challenges that discharges face today regarding Headworks design and primary clarification, especially in our economy. I wish to thank you for the opportunity to summarize some of our equipment solutions, and I look forward to discussing your particular challenges in more detail. Thank you very much for joining me today.